Observing the cauliflower. You can see that each part resembles the overall shape. Consider cutting a fragment from a shape. A figure in which the shape of a small fragment and the shape of the entire figure are similar is called a fractal figure. Examples include fern leaves, human lungs, coastlines, mountain terrain, cloud shapes, and galaxy distribution. Benoît Mandelbrot is a French mathematician and economist. He introduced the concept of fractals to understand the complexity of roughness. In parallel with his research in the natural sciences, he applied fractal theory to financial markets and economic phenomena.
Generally, in social sciences and natural sciences, some observed phenomena are close to the normal distribution, and the normal distribution curve is often used to understand the phenomena. The mean is mu, the standard deviation is sigma, and the interval from mu minus sigma to mu plus sigma is called 1 sigma. The probability that the data is within interval 1 sigma is about 68.27%. The probability that the data is within the interval 2 sigma is about 95.45%. The probability that the data is within the interval 3 sigma is about 99.73%. In the manufacturing industry, 3 sigma is treated as a guideline for control values if the product quality is detected to exceed 3 sigma. It is considered that the product quality is not satisfied. The mainstream of economics in the 1960s was to think that the distribution of price fluctuations followed a normal distribution.
However, as a result of Mandelbrot's analysis of the distribution of price fluctuations in the New York market, he found that it was not a simple normal distribution. With a normal distribution, fluctuations beyond the 5.5 sigma interval occur once in 72,090. That is, once in the Homo sapiens era. But in reality they have occurred many times. With a normal distribution, Black Monday, the 1987 stock plunge, was about 36 sigma. This was not possible in the history of the universe. Mandelbrot considered the distribution of price fluctuations to be a power law distribution, rather than a normal distribution. Assuming that the price fluctuation distribution is a power law distribution, he can accommodate much more large price fluctuations than the normal distribution, which is consistent with the actual data. In addition, while examining the distribution of cotton prices in power law distribution, he found that the monthly and daily distributions were similar. So he found that the distributions were similar across different time scales. By graphing price fluctuations, which are not shapes, he found a fractal figure. Charts draw waves on a long time scale, overlaid with waves on a short time scale. Summarize Mandelbrot's ideas. Market prices are volatile. The part of the chart that fluctuates drastically has a similar relationship with the entire chart. There is a long-term correlation, and the phenomenon that occurs here affects the phenomenon that occurs elsewhere long after, causing large fluctuations that far exceed the average of the normal distribution. The market behaves the same anytime, anywhere. Fluctuations occur many times in a short period of time, showing discontinuous and rapid changes from one price to the next price. Prices often jump discontinuously. Markets are inherently uncertain, and bubbles are inevitable. These phenomena can be explained by a mathematical model based on fractals. The Mandelbrot set is a famous set, He drew using a computer. When we magnify the figure, the same shape appears many times, inviting us to a mysterious world. Thank you for watching this video. See you next time.